Today we're going to take a look at reflections and line symmetry along with rotational symmetry. Symmetry is often found in nature. Reflection is a transformation. It reflects every point in a figure over a given line. Let's consider this example where triangle ABC has been reflected across the y-axis, and the image triangle A prime B prime C prime is congruent to the pre-image. Therefore, a reflection is an isometry. If I were to reflect this quadrilateral across the horizontal line, y equals 4, I could do it point by point. And then I would connect those vertices, and there is my reflected quadrilateral, again, which is congruent to the pre-image. Now, reflecting across a sloped line is a little bit more challenging, but if you use the coordinates, it actually is reasonable. If you think about the line y equals x, that's where every x coordinate equals the y coordinate. So what we want to do to reflect the quadrilateral across the line y equals x is for each vertex replace the x and the y coordinates. For example, vertex j has coordinates -3, 5. So j prime will become 5, -3. K prime will become 8, 0. L prime will be 5, 3, and M prime will become 1, 0. So here we will plot just the vertices, and then we will connect those vertices with straight edge, and there is our quadrilateral reflected across the line y equals x. Symmetry. If you were to fold this shape on that blue line, it would fold onto itself. So line symmetry is one type of symmetry. The heart definitely has one line of symmetry, but that quadrilateral has no lines of symmetry. Rotational symmetry is another type, and a rotation is also an isometry. So if I were to rotate this triangle 180 degrees around point R, basically I want you to consider 180 degrees is a straight line. So let's take line segment SR and let's extend it towards the west. Let's take line segment RT and extend it north instead of south. So here point T prime would be 2 above the point of rotation, and point S prime would be 4 to the west of the point of rotation. And then we would just connect our reflected points, and there is the rotation of triangle RST. So rotational symmetry is a type of symmetry that has to do with the number of times you can rotate a figure so that it basically coincides onto itself. Here in this square, if I rotated it 90 degrees, it would land back on itself. And I could do that 4 times over before the original orientation was met again. So this has rotational symmetry of 90 degrees, and the order is 4. Okay, the letter N, if I were to rotate it 90 degrees, it would not lie flat on itself, but another 90 degrees it would. So therefore, this has 180 degree rotational symmetry. The order is 2. This one, of course, is 90 degrees. We discussed that in the previous slide. This next shape that looks like a river has no rotational symmetry. But the regular pentagon, I could rotate it 360 degrees divided by 5, which is 72 degrees, and the order of symmetry is 5. So let's summarize. Here we have an equilateral triangle. It definitely has 3 lines of symmetry which are shown. So if I were to fold it on any of these 3 lines, it would fold onto itself. Similarly, I could rotate it 180 degrees divided by 3. I could rotate it 360 degrees divided by 3, which is 120 degrees. So the order of rotational symmetry is 3 for this equilateral triangle.